Okay.
Okay, so I'm going to have you come stand over here. We're good, don't worry. So I'm going to say the little blah, 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 and then I'm going to say, please join me in welcoming them to the stage. And that's when they go on. People have been clapping when you actually get on, so don't worry about that. Welcome again to the Developer Week Austin 2019. I would like to introduce your next speaker, Nathan Elliott, the CEO of Greenfield. Please join me in welcoming them to the stage.
Hello. Apologies, we're having a little bit of technical difficulty with setup. We should be ready momentarily. Hi, my name is Nathaniel Elliott. I'm the CEO of the Greenfield Guild. I'm also a 2-year veteran of the software industry, and I'm a guy who collects and invents metaphors, and if the slide wasn't clear, I'm also kind of embarrassingly Anglophilic. So I'll be talking today about the ways that computer security has been changing in the last few years and the ways that operations have been evolving in tooling and approach. These will set the stage for a discussion of evergreen development, which is a collection of operational practices which I recommend to address these security issues. I'll finish up with a suggested stack for implementing these practices. All of this will be wrapped up in an extended metaphor about trees. Sorry, I'm getting used to this tooling. Okay, so first, the evolution and threat model. Security is an ever-changing problem. The attack surface has been expanding dramatically, thanks in part to smartphones and the Internet of Things. There are more targets, more interfaces on these targets, and more real value behind these interfaces. This is probably the final nail in the coffin of the perimeter security model, which relied on keeping bad actors out at the firewall. IT can't effectively manage the large variety of devices their employees use, which means that any consumer device could be the vector for an attack inside your network. Because anybody's device could be compromised, security now has to treat each user with more distrust. This is known as the principle of least authority, and it's coincidentally also enforced by several regulatory regimes. For this and other good reasons, I'm not going to go into all of that a lot, but it's worth investigating if you don't already know about it. Meanwhile, the bad actors are getting more sophisticated. Advanced persistent threats are now big criminal business and sometimes big government business. Since the perimeter defense model is well known, its compromises are also well known, making it doubly ineffective. The value of mutability has also been well proven, since it's often far more expensive to close a security hole than to exploit one. Being able to, I apologize. It's often far more expensive to close a security hole than exploit one. Being able to switch to exploiting new vulnerabilities keeps attackers far ahead. All of which is unfortunate because our exposed vulnerabilities aren't getting any younger. According to Black Duck's 2018 open source vulnerability report, the average reported age for vulnerabilities in deployed open source infrastructure was 6 years old. And as many as 85% of targeted attacks are preventable via regular patching. All of this means that rapid defense in depth is now a necessity if you want to have any hopes of keeping your infrastructure secure. You need to be able to rapidly fix problems, and you need to be able to do that throughout your software stack. In short, continuous deployment is no longer optional. And I'm having issues. Apologies, I don't control both screens. And also, where have we gotten to? Okay, so that leads us to the evolution in operations. Once upon a time, deployment was a more or less manual process, often assisted by lengthy documentation called runbooks. configuration and ad hoc ops scripts. Configuration management tools like Puppet and Chef grew out of the attempts to standardize and automate these practices that old operations did manually. Container orchestration tools like Kubernetes and Mesos instead play to the strengths of automation, often in exchange for upending more traditional build and install methods. Along with this came a shift in operational methods. The manual world often went hand in hand with the bastard operator from hell mentality, where operations had an antagonistic relationship with development. The DevOps movement grew out of the realization that that was dumb, and that operations and developers should work together to automate operations. Site reliability engineering is a closely related set of principles for operating highly automated systems, pioneered by Google and adopted and expanded upon by many DevOps-aligned businesses. Given all that, we're going to start with a couple of operational best practices that can help improve your security footing. The first is, have you tried turning it off and turning it back on again? You may laugh, but this is a rote response for a very good set of reasons. What's even better, if you strictly separate build, deploy, and release, you can turn it on before you turn it off again. So, all operations approaches aim for a repeatable architecture, but the evolved approaches generally get much better results. We do so because it turns out that recapitulation, which is a fancy word for just rebuild it from scratch, actually fixes many ills. There are two big ones for today's purposes. The first is historical drift. If a server is long-lived, it's probably had many poorly documented changes happen to it, making the current state of it hard to reason about. The second is vestigial infrastructure. Software deployed that has no current purpose, but is being kept around because of its connection or co-location to other hard-to-move parts. Immutable infrastructure is an approach which builds on repeatable infrastructure. It's an approach which is only easily available with container orchestration, and then only if you do it right. It relies on the principal separation of build, deploy, and release, like I said. A build collects all the static requirements, the libraries, the binaries, and whatnot, into a static container image. A deploy launches and configures that container within a given environment, and then a release exposes it to the actual workload that it's supposed to be managing. By separating build from deploy, you keep flaky build dependencies from affecting your deploy cycle. By separating deploy from release, you can turn it on and test the new it before you ever turn off the old version. Crash-only software is another similarly motivated approach from a developer side. It involves writing software which assumes that any exit is a crash, and therefore that any startup should be a quiet recovery. By starting from assuming the worst, the software is insulated from a lot of common failure modes, and this also feeds well into the next topic, chaos engineering. It's a related pair of radical ideas, first pioneered by Netflix in their Simian Army. The first idea is that it's easier to diagnose problems that you've caused intentionally. And the second is that it's easier to diagnose those problems at 10 a.m. on a Tuesday than it is at 3 a.m. on a Saturday when they happen naturally. Even so, this is a practice of inviting pain, which might seem foolish, but segues nicely into, if it's difficult, if it hurts, do it more often. We all have this natural tendency to shy away from things that are painful, like the gym. Turns out that operations is like the gym. You only get better at the things that you do regularly. If you don't exercise the painful process, it never really improves. So what hurts right now? Well, upgrading dependencies hurts. Libraries and binaries. After all, you might break something. So as a result, upgrades are usually delayed. To avoid mutation in infrastructure that isn't actually immutable. When we actually do the upgrade, the changes are often batched together, resulting obfuscating the source of resulting issues. Major upgrades are harder if you're moving more than one major version, which we probably are because we put it off as long as we could. And even if we aren't, it's often easier if we're moving from the latest minor version of the prior one, which we often are because we often put it off. On the operations side, rebuilding infrastructure is a painful process. It's full of hard to reconstruct build chains because the last time we did it, it wasn't so well documented. And we've changed how we do things since then anyway. There are strange blockers because systems end up co-located. We can't upgrade PHP without upgrading Apache, but we can't upgrade Apache because that'll break Tomcat. Or they contain circular dependencies which require upgrading both sides of an interface at once. Even if we deploy the new versions successfully, fragile downstream services could be affected by performance changes, and we could be blamed. Because of all of this, security patching really hurts. You can rebuild your infrastructure and upgrade dependencies regularly, but nobody actually does that well today. Or you can play the patch and pray game, where you weigh each update's difficulty against the associated vulnerability and hope that you pick the right balance between stability and vulnerability. Or you can just abdicate entirely and hope nobody thinks you're a good target until you change jobs, which seems a common default, unfortunately. And it's unfortunate because until security patching doesn't hurt, attackers won't even need 0 days to get into your systems. Currently, well-known vulnerabilities let attackers in easily, and long-lived infrastructure lets them stay there indefinitely. That means that most software infrastructure today is pretty open to disaster, and inability to patch quickly is a prime suspect. Here we come to the metaphor portion of the talk. Traditional forest fire management has unfortunately proven very bad for forests. By interrupting the natural fire cycle of a forest, traditional management allows a buildup of dead wood in the undergrowth. This produces hotter, wider ranging, and more destructive fires, which often overwhelm the resources of firefighters. Traditional operations does not see the forest fire for the trees. Traditional operations, like traditional forest fire management, focuses mostly on fighting fires. We used to brag to one another about the uptime of our servers because that meant that systems they supported were probably also stable. Unfortunately, constant firefighting leaves little time for good engineering, and so people most empowered to cleanly rebuild old systems rarely have the time to do so. Growth-only focus in the development process produces a lot of this dead wood, aka technical debt. Technical debt is often poorly defined and even more poorly represented on balance sheets. So most businesses don't see the accumulating piles of existential risk that their technical debt represents. Even when they do, they often come real late to this realization and are already deeply in debt, and have no coordinated way to pay this down. As a result, if and when a breakout wildfire does occur, even heroic efforts are unlikely to be incredibly successful. If an advanced persistent threat gets into a traditionally operated company, it's pretty much there until it decides to leave. There's too many vulnerabilities, and there's too little that ops and security is empowered to do to close those quickly. Or your systems could just succumb to fragility and obfuscation, so that performance problems destroy profits without any clear cause or good warning that the loss is occurring. In either case, even if the fire doesn't destroy the company itself, good people on the front lines will be lost, either as scapegoats or quitting out of frustration, and that further endangers your company's ability to respond. By contrast, a more healthy fire management system allows the natural fire cycle to continue while protecting human property and lives. A natural wildfire is somewhat disruptive to the ecosystem, but far less so than a big wildfire fed by dead wood. Most animals can evade this fire and return when it is burnt out. Vegetation comes back quicker, restoring balance to the ecosystem before rains can wash away the topsoil. After a natural fire, evergreens are one of the first things to come back. They grow quicker compared to leafy trees and are even optimized for the fire cycle, having seeds that will wait to open until a fire passes. So what is evergreen development exactly? The first part is a practice called push on green. Again, pioneered at Google. Your continuous deployment system automatically builds the latest version of any check-in, and you can add a thing that upgrades your dependencies regularly as well. This ensures uncontroversial upgrades happen without any boring toil. Toil, incidentally, is another cause of vulnerability and error. Distracted humans often do things slightly wrong, and so eliminating that is a good knock-on effect to some of this. The second part of this practice is regularly releasing and redeploying all of your systems, including the underlying infrastructure. Practices like canary releases, testing performance by sending a subset of actual work to newly released versions, or rather newly deployed, I apologize, can help make this more automatic and less painful over time. You can also make allowances towards efficiency, like persistent data volumes for databases in Hadoop and the like, while still keeping software itself up to date. By recapitulating regularly, we can exercise and validate our ability to recover from failures everywhere. So persistent failures here should be considered a critical issue, even if they don't directly affect production performance. As I've mentioned before, batching changes often obfuscates the source of pain. By patching and redeploying regularly, you segment the problem space. Each small update contains fewer changes than the large one did, making causes easier to identify. The same goes for the history of servers. More regular rebuilds mean systems with histories that are shorter and easier to reason about. That's why and how, if it hurts, do it more often, actually works. None of this is particularly novel thinking, save maybe the insistence on doing it at every layer. It's just insisting on existing common sense operational principles and treating stability and security as first order targets rather than as afterthoughts to the march of features. So we've hit the 4 of the 5 W's. Let's hit how. So the tools I'm recommending here will work, but they're not the only way. They're not even the way that we'll do 100% of the time. So I'm going to talk in generalities rather than deep specifics at this point. So making recapitulation more automatic is a two-pronged approach. Converting the vast majority of your infrastructure into Kubernetes containers gives you application-level recapitulation largely for free. Automating the remaining infrastructure, hopefully just Kubernetes itself, but realistically, there are going to be some things that business needs, et cetera, prevent you from deploying inside, can generally be addressed by Terraform. Terraform is less flexible and a bit more confusing than Kubernetes, in my opinion, but it's the best open infrastructure tool I've found that can address multiple platforms, and it can also address some of the bare metal problem. Bare metal is extra tough. Contrary to the name, the environments are anything but bare, and each often has instead unique constraints. Tools like Rebar or Cobbler can provide some netboot support, which can help, but they're complicated. Where possible, I recommend leveraging existing deployment systems to get you to the Kubernetes layer. Really, all you need is Docker, and then a Rancher can take it the rest of the way. And then working back to better infrastructure deployment once container orchestration has demonstrated its value. Once you have automatic recapitulation, regular push-on-green rebuilds of your code base are pretty simple to build out in your favorite CI system, because Jenkins is everyone's favorite, right? Unless you've got a Greenfield project, individual applications are probably the low-hanging fruit here, but don't neglect the infrastructure. Infrastructure is always a juicier target for attackers, especially as your apps become better secured. Finally, automate the opening of problem tickets when these rebuilds fail, and keep treating them as business critical. Developer culture is often focused about fixing the build if you break it, and that won't work as well when it's an automated system. The right answer, I think, is to treat it as part of your team's incident response. It's an outside source of failure like anything else. The wrong answer is to pin it to the version that did work, backlog the ticket, and never change it. Wrong answer may be a necessary evil in some instances, but please don't let that dead wood pile up. Okay, that was a lot to cover in about 20-some minutes. I'll take some questions now, or you can come find me afterwards. Though if you have a question, maybe wave your hand around. I'm kind of blinded by the light up here. Okay, looks like no questions. Be glad to talk to individuals after. Thank you.